So we're going to talk about a bunch of fun stuff, world models, where we're going, but I think it's important to talk about this moment we're in right now and how we got here. You know, for all the talk about reaching super intelligence, right now what we have is machines that don't really understand anything other than everything ever written. And what does that mean for the limits of where we can get today?
Yeah. I mean, I think if we reduce it to that, it would maybe be a little bit unfair, but it is appropriate to say that most of what we call artificial intelligence today and the foundation models that we experience every day and probably the products that we mostly use are trained largely on this huge corpus of text that was available and easily scrapable on the internet. And I think there was, to a large extent, a practicality. There was a breakthrough innovation also with the transformer architecture and predicting the next token and all that conversation. And the models used today, a language, they feed in text and videos to some extent, but they certainly have a pretty poor understanding of time and space, which is very much unlike human intelligence, which is extremely rooted in time and space. And so when we look at these models and we think, what is the path to superintelligence or artificial general intelligence, however you want to call it, I think it's a bit of a trap to think we just scale that further and go down a path that is primarily verbal or language-based. We probably have to get closer to how human and animal intelligence and creativity originated, which is very much rooted in our being and our existence in space and time.
And so before we get into the idea of world models, how many people have heard the term and think they understand? Well, how many people have heard the term world models? How many people think they know what we mean when we're talking about world models?
We might call on you.
Yeah. So let's explain the term, and then actually it's fair if you have a different concept than the person next to you, because people do mean different things when they talk about world models. When we're talking about world models, generally, I think where there is agreement is we mean a model that understands how the physical world operates. It has a sense of physics. It has a sense of space and time. But then from there, some people are talking about how to run a robot. Some people are talking about how to play a video game. How do you think of world models, and how does that maybe differ from other concepts that are out there?
Yeah, most people will probably have seen world models in the context of live-generated videos online. I think the most prominent product is maybe DeepMind's Genie 3, where video generation has gone so good that we can actually generate the next frame, effectively 60 times per second live. That eventually creates the sensation of a live-generated video game. We kind of like worked our way through the modalities. We started with text. We have generative sound and music. We have generative images. We have generative videos. And now we have generative live video. And if you think about what a video game is, it's even hidden in the name. It's a video game. It's a playable video, generating videos so well and so fast that they become interactive. I think that typically comes to mind for people when they think about world models. The term is actually also used for a related class of models, which are action models and action policies. And so these are more concerned not with generating a world or generating some type of media, but action models and action policies try to analyze and perform the best action in a world. So you give this model a world, and that can be a virtual world like a video game. It can also be a capture of reality, and you give it a goal. And based on the data it has learned, it will predict what is the next best action. How can I optimally play this video game? Or maybe more interestingly, how can I navigate reality in an ideal way? Whether that be robotics, drones, we see a lot of applications in warfare and defense as well. And so, technically there is a difference between world models, which is generating the next frame, and action models generating the next action, but they're very closely related.
And some are generating new virtual worlds, some are helping us understand the actual world we inhabit. How does this help close the gap? How can world models, because they're more expensive in a lot of ways to build, more time consuming, there's less training data in some ways. How does this help? Why should we care?
Yeah, I'm going to go on a little bit of a philosophical detour here if you'll entertain me. Again, think about what models do today. They're extremely good at text, they're extremely good at language. And we treat it as intelligence, and maybe intelligence can scale to human levels or superhuman levels and superhuman creativity and intuition and all that kind of stuff. But I think a really important takeaway from today is that language is a function of intelligence and not the other way around. So language was something that emerged from human intelligence. For 2/3 of our existence, we didn't even have proper language. And we're still intelligent creatures. Toddlers learning to walk has nothing to do with language. Arguably, that's knowledge acquisition. Animals learning to climb has nothing to do with language. And so language was a construct, it was a product of our pre-existing intelligence. And so it can't be the ultimate solution. It's very efficient. It was important for many, many things, of course. I mean, Harari writes great books about it all, knowledge transfer, organization of societies, all that good stuff, shared beliefs, religions, knowledge outliving its creators, and all these kind of things. But it's not the cradle of human intelligence or animal intelligence, for that matter. How would we like to train intelligence from first principles? Probably closer to how we also acquire knowledge and understanding of the world, especially in the early stages of our life. Unfortunately, it's much harder to throw that stuff into a model. We have great online records of all we wrote and thought about. We don't really have a great discrete record of the sum of human actions and intent and the consequences that arose from it. It's much more messy and harder to collect, but we're working on that. And one way to think about it is also we want to make this new class of foundation models not just book smart, we want to make it street smart.
And there are some pathways to getting there. It is hard. There's a reason that every year for the last 10 years at CES, you've seen a robot trying to fold laundry, and we're all still folding laundry by ourselves. Mm-hmm. Like, these tasks that are pretty simple are actually pretty hard to replicate. What are some of the ways we get to world models? I know one that's of particular interest to you is video games. It's fascinating. Video games and chess always seem to be the necessary ingredients to get us to that sort of. How can video games help us get to world models, and what is it that we get when we get there?
Yeah, I mean, first of all, it's probably worth noting that video games have a rich history of driving forward technology and innovation that far exceeds use cases just for media and entertainment. To note, NVIDIA, the highest valued company on the planet, started as a video game company producing graphic cards for 3D calculations. And a lot of algorithm design, a lot of original machine learning actually originated from problems that were solved for entertainment and video game purposes initially. In this particular case, if you think about what the perfect data set would look like here, and it's not like we haven't been trying to do this before. Actually, before language models took off and before the transformer architecture took off, the path was closer to trying to do machine learning, reinforcement learning that was more spatial, more temporal, but we just never had a good data set to work with. The perfect data set would be collecting intent and action data from humans in the real world. We'll probably have to run around with brain-computer interfaces, gonna come eventually, not there yet and not there for a while, to collect what do we want to do, what did we actually do, how did the environment respond, what is the objective function or the goal at any given time, what's the goal right here, right now, what's your goal, how do we measure it, what are you thinking, what are you saying, what happened after. Like, it's very hard to collect that kind of stuff. And when we come to video games, we actually have obviously a bit of an abstract version of realities and worlds, and some are fantastical, some are very realistic, but we do have very discrete information about, often from a first-person perspective, the precise actions and input that went into certain activities. And so you don't only have the environmental data or the video data of what actually happens, like recordings of us. We have plenty of that on YouTube. Again, it's getting to these like action and intent signals, and we get them from from mouse movement, mouse clicks, keyboard clicks. We get them from controller inputs and various other means. And the fascinating thing, and this is where this kind of gets crazy, is if you do this across a sufficient number of games, with a sufficient varieties of players, with a sufficient distribution of outcomes and edge cases, the model can actually generalize and can perform ideal actions in cases it's never seen before. And we're not just talking about throwing one of these models into a video game it's never seen before. We can even throw these agents or action models or policies into real situations, into reality situations, tell them what to do, and they go about and do it.
So I want to skip ahead a little because we don't have that much time. And where does this get us? What do you think we'll be able to do in a few years of having these world models that we haven't been able to do by having large language models for a few years now?
Yeah. The most common use case for this, that is already live today, by the way, is autonomous driving. This was a use case where we collected world data and action data and human data, steering, for a narrow data set, for a narrow use case. Now the quest is to basically build agents and action policies that are much more generalizable. And they will find their ways immediately into topics like robotics. So this is a use case where, previous robots were pretty static. They did exact things in an exact manner. They knew where to pick things up and to put them down. And if things were just a little bit awry, there was no ability there to reason and truly understand the task at heart, to improvise and these kind of things, especially as robots move into the household, as they interact closer and need to safely interact with humans. That is an application area. We do see a lot of applications in warfare, drone warfare specifically. And they do, in the end, also have applications in video games. They make smarter bots. They can help adjust games for the ideal level of difficulty to maximize engagement and retention. They have media applications ultimately as well.
So some of those applications sound more exciting to me than others. Some of them sound a little more scary than others. We're at this moment in time, and I feel like I've been saying this for the last 6 months. It feels to me we're in the exact moment where in all the science fiction movies, everyone goes back and says, let's destroy everything because here's where it went wrong. How do we not do that? How do we take the technology we have, keep it going, but not have a world of killer robots, a world of drones that are really good at killing people but really bad at knowing why not to kill people? How do we take the technology and use it for good?
The headline's going to read, at long last, we have built the world model from the cautious sci-fi novel, Don't Build the World Model. I don't have a great answer for you. The only answer I do have thinking about this is, I think the technological progress is effectively unstoppable. I think we will get to solutions and we will get to action policies that can navigate time and space better than humans in pretty much anything that humans can do. Just like I think we will get to true superintelligence in kind of like language and just a purely digital realm. This has profound implications, but it also has profound implications, I think, for the West to master this before maybe other actors figure it out, because someone will figure it out. And I think ultimately, the best argument for working on it when there are negative externalities that are on the horizon is that this technology will be built anyway, and I think the more we can work on it being in the right hands, and that's obviously a political and philosophical statements. If we can put it in the right hands once it works, then I think that's our duty to work on that.
All right, we have just about a minute left. Tell me one thing you're excited about that will come about because of these world models, besides really great video games, because I know that's your first answer.
I'll plug something, another interesting technology conversation that you'll be having tomorrow, because I think there are really two super exciting tech topics as it relates to AI in 2026. There's more of the existing stuff, which is agent and enterprise adoption and all kind of that's all going to continue and go about it. But from a tech perspective, I think world models is one of the exciting potential breakthrough topics for this year. The other one that I really think is important is kind of continuous self-improvement of models, not just shipping static models, but shipping something with a fundamentally different architecture that can take an information, redistribute itself, and kind of like morph. And so that's something you'll be talking about tomorrow, I think, with Richard.
So the good news is Richard Socher and I from U.com will be talking about this tomorrow. But again, that's also really exciting and really fraught, this idea that the models can get better on their own. You're also not worried that's a direction that sci-fi has warned us not to go?
I stopped worrying about it and kind of like learned to love the machine. And I think that's the path we're down at this point.
All right. Well, that's a scary note to leave things at, but we'll leave it with, don't worry, trust the scary robot. Moritz, thank you so much.